So in this video, we're going to look at how we can divide polynomials using synthetic division when the divisor has a coefficient in front of the x. So what we mean by this is that if we are dividing by a divisor that looks something like, 3x plus 4, or maybe it's 2x minus 5. Noticing here that unlike the examples we've seen in the past, there's a coefficient here for x. I'm talking about how that slightly changes the problem and how we can still use synthetic division here. We just have to be a little bit more careful. So if you look closely here, you'll notice that this particular divisor has a coefficient of 3 in front of that x. And truly, what's difficult about synthetic division is that while synthetic division is really convenient and is a nice little pattern to quickly divide polynomials, it only works if your coefficient of x in your divisor is 1. So what we actually have to do in this entire problem is we have to go through and we have to divide every single term in both the dividend and the divisor by 3. Now what you're probably imagining is that this is going to become a little bit nasty and gross because there's going to be fractions. Yes. And this is an instance where sometimes people actually choose to use polynomial long division instead of synthetic division because it does get so complicated. So if we divide every single term in there, both the dividend and the divisor, by 3, we end up with 2x cubed minus 16 over 3x squared plus 17 over 3x minus 8 over 3, and we're dividing that by x minus 2/3. So now that we've rewritten this in this way, we can easily see that our k value is equal to 2/3. So we can at least now set up our synthetic division. So here we're going to have 2/3 as our k value. Then we have 2 negative 16 over 3, 17 over 3, and negative 8 over 3. And I'm going to strongly suggest you leave everything as fractions, as it's going to just make things a little bit easier. So here we drop this down and this becomes 2. And then we have to take 2 times our k value here, which is 2/3. So we take 2 times 2/3. To multiply fractions, we put the 2 over 1 and we multiply across, so we get 4/3. So here we're going to put a 4/3. Now if we leave this in terms of thirds, this actually isn't too bad. So now if we add straight down, what you should be noticing is that we have negative 16 over 3 and 4 over 3, and because those have common denominators, those simply add to be negative 12 over 3. Now, I know it's really tempting to turn that into a number, which we can do. So negative 12 over 3, we should be able to turn into a negative 4. Okay, so we have our next number. Then we repeat this process. We take 2/3 and we multiply it by a negative 4. So we have negative 4 over 1 times 2/3. That becomes negative 8 over 3. So we have negative 8 over 3 here, and we can add that together with 17/3 because they have common denominators. So that's going to become a positive 9 over 3, which that simplifies down to be 3. So that's kind of nifty that worked out well. And then from here we have to multiply the 3 times the 2/3. That becomes 6 over 3. Now you can change that to be 2 if you would like. Just notice that you're going to be adding that together with a fraction. So I'm actually going to leave it as 6 over 3 just so it's easier to add together there. So from here, this becomes negative 2 over 3. So we've now used synthetic division to solve this all the way through. We know that this is our remainder. This is our constant. This is our x, and this is our x squared. So if we start to write this out, we can write this as 2x squared minus 4x plus 3. And then our divisor here is negative 2/3 over x minus 2/3. Now, it's not really good practice to keep fractions within fractions like this, but luckily, because we can see that we have the denominator of 3 as our problem, if we multiply everything in the top by 3 and everything in the bottom by 3, so we multiply all of the terms by 3, we're not actually changing the integrity of the problem. So if we do so, negative 2/3 times 3 becomes a negative 6/3, which is negative 2. So that can be a negative 2 in the top, and then if we multiply everything in the bottom by 3, x times 3 simply becomes 3x, and then again we have another negative 2/3 times 3, so that becomes minus 2. So what we can do is we can rewrite this entire remainder here so that it's just one fraction, not two fractions. And you'll notice we just multiplied every term in the numerator and every term in the denominator by that fraction that was a problem. So that was the 3 in the denominator that was the problem. So we multiplied all of the terms by 3, and we ended up with negative 2/3x minus 2. So you can see how synthetic division still works here, but it does take a little bit more work when our divisor starts off with a coefficient for x that is not 1.